Okay. So using the relationships from this first section here, we're just going to use these general equations. Okay. Um, so we know that if we relate, so the two pressures are equal, right? So so in this problem, I'm given a couple of things, right? I'm given, okay, so a circular cross section and a radius of 5 centimeters. The pressure is transmitted by liquid by piston to a radius of 15 centimeters. So I have like two circular tubes, okay? And when they say area, what they mean is the cross-sectional area. So if I'm applying some force, right, to one tube, and I want to have a force coming out of the other tube, right? I'm applying on this side. This is my F1, this is my F2, similar to what we see up here in kind of this drawing. I know from up here that I can relate them and say F1 over A1 would be equal to F2 over A2, because I'm saying that P1 is equal to P2, right? So we're going to use this relationship here. Okay. So what am I given in my problem? Okay. So let's talk about A1. I'm given a radius and it's a circular cross section. Okay. So for circular cross section, I need to find the area of my circular cross section. So my area is going to be equal to pi r squared. Okay. So I'm given one radius for the first side, right? On this side, the radius is equal, so exerts a force on the small piston. So the radius on this side, R1, is equal to 5 centimeters. Okay. And then the radius on the other side, R2, is equal to 15 centimeters. Okay. So now I want to find A1 and A2, right? So for A1, I'm going to have, so pi R1 squared. And then for A2, I'm going to have pi R2 squared. And so that's going to be pi, and then what is centimeters to, so 5 times 10 to the negative 2 meters squared. Okay, and this is going to be pi times 15 times 10 to the negative 2. So this should say 10. My handwriting isn't the best here. Squared. Okay, so I found the cross-sectional area for both of those. I also want the force that's coming out to be equal to this, 13,300 newtons, right? It's a very large force. So we're going to say that's 1.33 times 10 to the 4th newtons. Okay, so I have this relationship here, right? I'm going to say that F1 over A1 is equal to F2, right, over A2. And my goal is I want to find the force that I need to put in to cause this force F2. So at this point, it's just going to turn into algebra for me. I'm going to have F1 is equal to A1 over A2 times F2, right? So I'm given an F2 that I want to exert, okay? My F2 is this. That's what I want to come out. And then I can find the circular cross section from the two radiuses. So if I just plug in all of these numbers that I have right here, right, I plug in all of these guys, my A1, A2, and my F2, my answer for F1 is going to be 1.48 times 10 to the 3rd newtons, what we put right up here, okay? So that's what this expression means. That's what Pascal's law is telling us. We can relate the pressures on two different sides, so long as we have an incompressible fluid, and we can show how the force on one side will affect the force on the other side, just dependent on that cross-sectional area. So yeah, so just relating the pressures. Okay, so what about the second part? Well, now that we have F1, all we need to do is go ahead and plug that into the second part over there. So 1.48 times 10 to the negative 3, right, for F1. And then we know that our area for A1, we found that one before. That was pi 5 times 10 to the negative 3. And it's times 10 to the negative 3 because it was, or sorry, negative 2, because it was centimeters, negative 2 meters squared. And then we're going to say that our P1 is going to be what air pressure produces this force. So our P1 is going to be equal to F1 over A1. So we're just going to plug in our F1 and then our A1 values, and we're going to get a pressure of what we have right here, which is 1.88 times 10 to the 5th pascals. Okay, so yeah. So I think that it helps kind of like seeing an example of like how you'd apply the equations and how you'd actually use them to solve a problem. Okay, so let's kind of, this one is a little bit different. This one uses the earlier equation, not this guy, not this relationship, but instead uses this relationship, just for another example problem for that one. So I will go ahead and leave this problem here, and I'm going to go ahead and press pause and give you guys a chance to try this one as well.